Alright, this function is defined as f of x equals x minus log of 1 plus x squared. Show that f dash of x is negative, never negative. Alright, so when we differentiate x, we get 1. When we differentiate a log, we get the log of a function, we get the f dash of the function on top of the function. So we get 2x on 1 plus x squared there. So 1 minus 2x on 1 plus x squared. Now, a funny thing that you can do, if we go back to what we know from our inequality proofs, we'll do it this way because it turns out nicely. We know that's going to be positive. We also know then that if I expand that, so I get 1 minus 2x plus x squared, that's always going to be positive. If I keep the 1 plus x squared on this side, 2x on the other side, this is for yeah, this is okay. We can so we're just subtracting, we're just adding that 2x to both sides, so that's fine. Sorry, I just had to check. Now I can divide through by 1 plus x squared because I know 1 plus x squared is always positive. So I can divide through by 1 plus x squared, and you can see then I can subtract that 2x on 1 plus x squared, and I get that it's always positive. So we've shown that this is always positive, it's always greater than 0. It's equal to 0 when our x equals 1. We're going to get 1 minus 1 is 0, but otherwise it's always greater than. So anyway, f dash of x is never negative. Alright, explain why the graph lies completely above the x-axis for x is greater than 0. Well, we've shown that the gradient is always positive. So if we look at the value where x equals 0, so f of 0, where does it start from? So we've got 0, take away log of 1 plus 0. Well, that's just log 1 is 0, so 0. So it starts from 0, 0, and the gradient is always positive. Whatever it does, it's always positive. Okay, hence prove that. Okay, so we are looking just for positive values of x's, and clearly we want to use what we've already done. So what have we already done? Well, we've already shown that this function, we just showed in B, we had to say that it always lies above the x-axis. So let's start with that. So we always know that this is going to be greater than 0 for positive x. So it was equal to 0 at x equals 0, but so for positive 0, positive x, it's always going to be greater than. Alright, if we rearrange that a little bit and then exponentialize to get rid of the log, so we can do that, that's no problem, and we can exponentialize, so that'll be e to the x, because we know that when we exponentialize, if something was, so here's my exponential, if something was already greater than, so this value, x2 is greater than x1, then on the exponential where x is positive, e to the x, where x is positive, its y value will also be greater than the other one's y value, so it stays the same here. So we know that e to the x is greater than 1 plus x squared. That's what we wanted to show.